Hello everyone, my name is Anthony Pinzone. I'm from Kent State University in the Cardiovascular Dynamics Lab, and I'm here to present some research for you today. So what we'll be talking about here is a study that analyzed sex differences in response to an acute bout of resistance exercise and some cardiovascular parameters. So let's get into our measures. So the first thing I'd like to ask you all is, what do you know about pulse wave analysis? I mean, the answer is probably nothing. These measures aren't super prevalent. There may be 50 labs in the entire world that do these measures, but maybe I can provide some clarity and help you understand our study a bit more. So when talking about pulse wave analysis, what we really have is a way to quantify work being performed by the left ventricle during the cardiac cycle. So I like to use the example of an ocean wave to illustrate this example. I know we don't really have oceans out here in the Midwest, but I'm from New York, and back home we have the Atlantic Ocean, so that example really helps me understand. So like any ocean wave, you have a forward traveling wave, or when the wave is pushed out or rolls out to shore, and you have the backward traveling wave, where the tide of the wave is pulled back in. The same thing holds true in the cardiovasculature. So when your left ventricle contracts and forcefully exerts blood to systemic circulation, a forward traveling wave is created. When that blood bounces off the walls of your artery, or the arteries bifurcate or split off and blood is pushed back, a backward traveling or reflected wave is created. Augmentation pressure is simply the pressure needed for the forward traveling wave to overcome the backward traveling or the reflected wave. So the left ventricle must exert some level of pressure in order to do so. As far as augmentation index goes, augmentation index is simply the percentage of the pulse pressure or the total pressure of the wave that the augmentation pressure makes up. An augmentation index that's standardized at 75 beats per minute is derived from a computer algorithm that standardized the heart rate of all of our participants at 75 beats per minute and analyzes the augmentation index at that point. As far as hemodynamics go, we measured heart rate and systolic blood pressure at the brachial artery. So why do these measures matter? Elevations in these measures, so the hemodynamics, systolic blood pressure, and heart rate, as well as aortic wave reflection, so the augmentation pressure and index, have been associated with an increased risk of cardiovascular events. So while these measures are elevated, individuals have been documented to be at an increased risk of myocardial infarction or other adverse cardiovascular events. As far as sex differences go, in response to resistance exercise with these measures, that area has been particularly under-researched. So the aim of the study was to further understand sex differences in these measures, the aortic wave reflection and the hemodynamics, in response to an acute bout of resistance exercise in young, healthy men and women. What do we expect to see? We hypothesized that the resistance exercise condition would exhibit statistically significant increases in both the measures of hemodynamics and aortic wave reflection compared to a control condition. We also hypothesized that men would have a greater increase in these measures simply because they're moving more absolute load. So let's talk about our study background a little bit. So the study was control randomized, meaning participants were randomly assigned to a control condition, which entailed resting comfortably in a supine position on a table, or an acute resistance exercise condition, which I'll elaborate on in a minute. As far as our participants went, we had two groups, young healthy men and young healthy women. What did the exercise protocol look like? It was three sets of 10 at 75% 1RM on 5 different machine exercises: chest press, leg press, lat pull down, leg extension, leg curl. All exercises were interspersed by 2 minutes and performed in a circuit fashion. What were our time points? We measured heart rate, blood pressure, and our measures of aortic wave reflection at baseline or rest, and 10 minutes post-exercise recovery. Alright, so what do our results look like here? So if you take a look at our graphs, we'd see statistically significant increases among both men and women for heart rate, systolic blood pressure, and augmentation index at 75 beats per minute. The one thing that we did not expect to see was actually a statistically significant decrease in the augmentation pressure from rest to recovery for both men and women together. So what does this mean? Ultimately, men and women did respond similarly to the acute bout of resistance exercise. So both men and women had statistically significant elevations in heart rate, systolic blood pressure, and augmentation index at 75 beats per minute post-exercise compared to at rest or at baseline. So what is the practical application of this? Well, as I said before, these elevated measures of aortic wave reflection and hemodynamics have been positively correlated with increased risk of myocardial infarction or other adverse cardiovascular events. So perhaps the main takeaway is to avoid additional stressors 30 minutes post-exercise. Some really commonplace recovery modalities like immersing yourself in cold water or entering a hot tub or a sauna may further stress the cardiovasculature and may further increase the probability of suffering some type of adverse cardiovascular event. Thank you for your time today. Any questions?